Hello and welcome back. Here we want to go over a possible solution for the exercise where we implement a class for an account in a bank. So we were imagining that we are a bank and we need to establish a way for us to track interaction with customers, and we were keeping a very simple scenario where we have one account for each customer with the following properties. It's associated with their name. We only consider full euros, so no cents, just integer values, no other currencies. Customers can put money into the account, withdraw money and ask for the balance. They can't do anything else. And the bank doesn't offer any credits or overdraft. And we wanted to implement this as a class. So of course, we first needed to think about the requirements that are ambiguous or not sufficient and maybe come up with some strategies to do this. And also we need to think about other cases that can go wrong in our implementation. So we've already identified that names are not really detailed enough. Do we mean the full name, just the surname, the given name, any middle names, and also depending on the culture, the concept of a name may be different from what we expect in our Western world. So for simplicity, we just go for the surname for now as a single identifier. Obviously, that will go wrong down the line as many people share the same surname. And maybe people want to have same accounts, or married couples will have separate accounts and so on. But we ignore this for now. But in real life, of course, we need to be able to deal with this. We also don't have any specification for gender assignments. Again, we ignore this for now because we want to have a very, very simple case. When a withdrawal is made, we need to check that there are sufficient funds in the accounts because we don't offer credit or overdraft. And we need to withdraw a positive integer number, but we can't withdraw a negative number. And we can only withdraw the full value of the balance at most because there is no overdraft. And when we deposit money, we also need to check that the deposit is a positive integer number. So we can't, for example, have a deposit of minus 5,000 or whatever. So here is a very simple class that does this. And as we've seen from the long list of issues, that would in a real situation not be sufficient, but it allows us to handle the cases as well. So we define the class. We don't inherit because it's a simple class. We need to define the init function. Remember the special lambda versions underscore init underscore that we need to implement. And our class needs to have two parameters to start with, so a balance that we have a default argument of 0 and the name of the account holder. So both of them we designate as internal variables because whoever uses the account class should not interact with them. So we use underscore name and underscore balance in the self assignment here, and we make sure that we convert it to an int here. We should also really make sure that the name is a string, so this is another thing that can go wrong and needs to go to our long list of issues that we need to take care of in principle. But here we want to really have a minimal, easy implementation and see how we can work with classes. So we said that we need to work with balance, so the customer can acquire the balance that really just returns this internal variable. We also maybe want to acquire the name that is associated with this account because we don't want users to interact with the variable itself. The customers need to be able to make a deposit with a given amount. So first of all, we need to check that this is indeed an integer amount and not say a float or a string, and this amount is greater than 0. And if these conditions are met, we add this to the balance. Otherwise, we'll do a very simple error handling and just do a print statement and ignore the assignment. And for withdrawals, we also need to do the same thing. We need to check that it's an integer because we don't have cents and things, that the amount we withdraw is a positive number, and that we withdraw at most the balance. And then we update the value, and as a return value, we give the current balance. Otherwise, we print a statement that this doesn't work and return none. So how can we use it? We create an instance of this class for customer Smith, for example, and say the account was opened for name and has a current balance. Then we make a deposit, and then we try some invalid deposits, for example, negative numbers, non-integer or strings. And then we do the same for withdrawals. We do a correct withdrawals and then test for some cases that we have captured, negative numbers, float numbers, strings, or a large withdrawal that exceeds our funds. And we can see, at least in this case, the class behaves well. So this is like a minimal implementation of the account class, and as we've discussed before, we would need to do a lot more to make this really error safe and usable in a real world situation, but you can get the idea of how you would design a class.